Correct? Let's try to understand the difference between factor and multiple. Fine. Let's take factor. What is factor of 10? 1, 2, 5, 10. I'm writing directly now. Factor of 12. 1, 2, 3, 4, 6 and 12. On this side, let me write multiples. Multiples of 10. Multiples of 10. Correct? So 10, 20, 30, 40, 50 and so on. Multiples of 12. 12, 12 twos are 24. Next is 36, 48, 60, 72 and so on. So what do you observe? Multiple of 10 here, which are infinite in numbers. How many multiples you all have? Infinite. And how many factors does 10 have? Only 4. How many factors 12 have? 6. How many multiples 12 have? Infinite. So that is the first difference between factor and a multiple. Alright. First one. I am writing in brief. The number of factors of a given number are finite. The number is finite. Here a number has infinite multiples. Any number has finite factors. Any number has infinite multiples. That is one difference. Well, 1 is a factor of all numbers. Can you see that? And the number itself is also a factor of that number. 10 is a factor of 10. 12 is a factor of 12. And amongst the finite factors, the largest one is the number itself. Which is the largest factor of 10? 10, which is number itself. Which is the largest factor of 12? Which is 12, which is number itself. Correct? Okay. So, factor, second, largest factor of a number is the number itself. Let us find out the largest multiple of 10. What is largest multiple of 10? You don't know. Infinite. Does not exist. You cannot find the largest multiple of 10. You cannot find the largest multiple of 12. So, largest multiple of number does not exist. Or you can say it is a very big number, infinity, right? But we can say it does not exist. Anything else? Yeah, their definitions are different. What is factor? The number which divides the given number exactly. Factor is a number which divides the given number exactly. And what is multiple? Multiple is a number which is exactly divisible by a given number. Multiple is a number which is exactly divisible by a given number. So that's the difference between factor and multiple. Please pay attention, observe it nicely, because when I give you homework, there will be some tricky questions to answer. Okay? Fine. So we are done with factor and multiples. Fine. Let's see what are prime and composite number next. Okay, here I am going to write some positive numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's factors. You can find the factors by the method I'll show. We are going to see still easier method to find factors. Okay? And number of factors. And on that basis, you can decide the type of number, whether it is prime or composite. 1. It has only one factor, and that is 1. For all the numbers, 1 is a factor for sure. 1 is a factor for sure. Because 1 is a factor of all numbers. 1 divides every number exactly. So 1 is a factor. What about 2? 3, the other factor. 4, 2 also divides 4 exactly, and then 4. 5, 1 and 5 divides. 6, 1 divides 6 exactly, 2 divides 6 exactly, 3 divides 6 exactly, and 6 divides 6 exactly. 1 and 7. This you may find out. Okay? 2, 4, 8. 1, 3, 9. 1, 2, 5 and 10. So these are the factors. You can proceed further up to 100 children. I'll give you a list of this 100 numbers with their factors. Chalo, how many factors 1 has? 1. How many factors 2 has? 2. How many factors 3 has? 2. How many factors 4 has? 3. How many factors 5 has? 2. 6 has 4 factors. 7 has 2 factors. 8 has 4 factors. 9 has 3 factors. And 10 has 4 factors. And you can get the number of factors for the other numbers as well. Well, what do you observe? There are some numbers which have exactly 2 factors. Not less than 2, not more than 2. They have exactly 2 factors. Which are the numbers having exactly 2 factors? 2, 3, 5, 7. Children, such numbers are called prime numbers. Such numbers are called prime numbers. Okay. Then other numbers have 1, 3, 4, 4, 3, 4. If you go up to 100 and observe, only 1 has 1 factors and the rest all numbers have 3 or more than 3 factors. Matlab more than 2 factors. So you can divide all these numbers into 3 types. In one group, the numbers having exactly 2 factors. In another group, there is only one number having 1 factor. And the third group, which is huge one, okay, which has more than 2 factors. The numbers having exactly 2 factors are called prime numbers. And the numbers having more than 2 factors, they are called composite numbers. This is neither composite nor prime. It is called special number. This is called special number. 1 is called special number. What I have circled, they are prime numbers because they have exactly 2 factors. This is in the box. Special number is in the box. The circle numbers are primes and the rest of the numbers are composite numbers. So what is the definition of prime number? A number having exactly 2 factors is known as prime number. Examples. 2, 3, 5, 7 and so on, etc. What about composite numbers? A number having more than 2 factors is known as a composite number. Is known as a composite number. Example, well, it starts with 4. 4, 6, 8, 9, and 10. Children, lot of things to observe here, and tricky questions can be asked from here. Like, which is the smallest prime number? 2. Which is the smallest composite number? 4. Which is the only prime number? Look, all the prime numbers that you will find will be odd. The only even prime number is 2. Which is the smallest odd prime number? 3. Which are single digit prime numbers? 2, 3, 5 and 7. Which are single digit even numbers? 4, 6, 8, 10. Sometimes children forget this. Many children forget 9. It is also a composite number, not prime. Okay? Because it is divisible by 3 as well. So it has more than 2 factors. Okay? So understood what are prime numbers and composite numbers? Okay? I'm going to write prime numbers, all the prime numbers which are included in the numbers from 1 to 100. Okay? You too remember that. Try to remember that. It's very important. Ready? What we are going to do? Prime numbers from 1 to 100. Prime numbers from 1 to 100. Which is the first prime number? The only even prime number 2. Next, 3, 5, 7, 11, 13, 17, 19. After 19 it is 23, 29, 31. After that 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. These are all prime numbers. Look what I am doing. All prime numbers, observe them. I have used 2 colors to write them. One is red color, and the other color is black. What do you observe? The red colored number is the only even number, the rest all are odd numbers. Further also you will get odd numbers only. And why it is so? Okay, all even numbers other than 2 are even composite numbers. Every number has 2 factors. One is a factor of all number and the number itself. An even number other than 2 are divisible by 2. So 2 is a factor, third factor of every even number. 1 to the number itself and 2, because every even number is divisible by 2. More than 2 factors, that means it is composite number. Correct? So clear? What are prime, what are composite? Okay? Fine. We saw the definition also. We saw the examples. Alright. Now, we'll see what is HCF and LCF. Okay. First, we'll see what is HCF. Okay. HCF. Highest. H for highest. Common factor. F for factor. Sometimes it is also called GCD. In previous state board book it was GCD, because this factor is also called divisor, as I wrote earlier. This is greatest common divisor. Greatest common divisor. Let's try to understand what it is now. So let's observe and understand here. Observe and understand. Let's take 2 numbers 12 and 18. I'll directly write the factors of 12. You will have to find, right? Since it's a small number, you can write the factors directly. 1 is a factor of all number. So 1 is factor of 12 as well. 2 is a factor because 2 divides 12 exactly. 3 is a factor, 4 is a factor, 6 is a factor, and the number itself. 1 is factor of all number. Yes, 18 is exactly divisible by 2, 18 is exactly divisible by 3, 18 is exactly divisible by 6, it is exactly divisible by 9 and 18. So, got the factors? Correct. Now, I am going to find the common factors. Children, what do you mean by the word common? What do you mean by the word common? Well, Shyam is studying in 10th E1 and Ram is studying in 10th E2. What is common for these two students? Class 10. Both are in class 10. Alright. So, the standard is common. Alright. Sita is studying in 10 E1. Geeta is also studying in 10 E1. What is common? Class as well as division. Radha is studying in 9th E1 and Shyama is studying in 10th E1. Different standards, but division even. So what is common? Even. Okay. Rakesh has blue eyes and Naresh has blue eyes. What is common for them? Not eyes, the color of eyes, blue. Okay. So common means having same thing in respect of particular aspect. Okay. So what is common here? We have factors of 12, we have factors of 18. 1 is common factor because it is a factor of both 12 and 18. 2 is common factor. 3 is common factor. And 6 is common factor. Right? 4 is not. 4 is a factor of 12 but it is not a factor of 18. 9 is a factor of 18 but it's not a factor of 12. 12 is a factor of 12 but not factor of 18. 18 is factor of 18 but not factor of 12. So we found the common factors. From these common factors, which is the highest one? अरे उसी को कहते हैं highest common factor. So highest common factor of 12 and 18 is what? 6. In brief, HCF is 6. Symbolically we write HCF of 12 and 18 is equal to 6. So this is how we find the HCF. But again, this method is employed to understand exactly what is highest common factor of two numbers. Here, instead of taking two numbers, we can have three numbers. We'll write factors of all three numbers, then derive the common factors and then determine the highest one from them. Can we take one example of three numbers? Yes. Okay, our aim is to find HCF of three numbers 60, 48 and 36. Children, in the next session we will learn how to find the factors. In fact, today if we have enough time, we'll find the factors. I'll show you, okay, after this, how the factors of 60, 48 and 36 are obtained. Not by those age-old method, primitive method, okay, dividing and finding the factors. There's another tricky method and very easily you can find the factors. Quickly you can find the factors. Right now I'm going to write all factors of 60. 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 5 is a factor, 6 is a factor, 10 is a factor, 12 is a factor, 15 is a factor, 20 is a factor, 30 is a factor and 60 is a factor. These are factors of 60. 48. 1, 2, 3, yes. 4, yes. 5, no. 6, yes. 6 8s are 48. 4 12s are 48. 3 16s are 48. 2 24s are 48. And 1 48s are. They make a pair, children. They make a pair. See this. Pairs of factors which we were talking about. 10 is alone. 10 6s are. Something I missed out. 1, 2, 4, 5, 6, 7, 12, 1 and 60, 2 and 30, yeah, 3 and 30, 4 and 20, no, 4 and 15, 4 and 15, correct? Then 5 and 12 and 6 and 10. Fine. Okay, excuse me for that, but you can understand that. 36. 1, 2, 3, 4, 9, 12, 18 and 36. Alright. Fine. Common factors now. Find out. Common factors of 60, 48 and 36 are 1, 1, 1, 1 is common, 2, 2, 2, that is common, 3, 3, 3, it is common, 4, 4, 4, it is common, 5 is not common, 6 is common in first two but not in all three, 10, no, 12 is the next common factor, correct, 15 is not, no more common factors, no more common factors. Now I am going to write in brief, symbolically, HCF of 60, 48 and 36. Can you tell me what is that? Yes, the highest one is 12. So this is how we can find the HCF of three numbers. We are going to see different methods of finding HCF later, okay, in the later sessions. Fine. So understood how HCF is found? Okay. Now I am going to show you a simple method to find factors. Okay. I wrote those factors directly, but how can you find those factors? Which numbers? 60, 48, 36, 18, 12. Let's see how to find their factors. First, we'll find the factors of 60. It's big number, not that big too. First, I'll obtain its prime factors. 60 is divisible by 2. 2 30s are 60. This you know very well. 2 15s are. Now 15 is not divisible by 2. What is the next prime number that divides 15? 3. Yes, 3 5s are. Now 5 is not divisible by 3. So after 3, what is the next prime number which will divide 5? 5. Correct. 5 1s are. So what you have done is you have found the prime factors of 60. And what we need are all factors of 60. So what you do from prime factors, you get the pairs of factors first. How to do that? You know, 1 is a factor of all numbers. So first you write 1. 1 into 60, that number. 1 and the number itself, they are factors. So we made a pair of that. Can you get me? Okay. Now from the prime numbers, write more factors of 60. How? After 1, which number comes? 2. Is 2 a factor here? Yes, it is prime. So it is. It is there. Next, after 2, it's 3. And 3 is prime. So if it is, you will get from here 3. Yes. After 3 is 4. 4 is not prime. So you will not get 4 directly from here. But you can get indirectly if it is existing. How? 4. What are the prime? It is composite number. So it has its own prime factors. Double 2. Do we have double 2 here? Yes. 2 2s are 4. So 4 is the next number. Correct. 5. Is 5? 5 is prime. So you will get directly from here if it exists. Yes, it is there. And so 5. Then you take a breath. Just stop further. You find out the second factor. 2. What is the other factor? So you just hide 2. And whatever remaining prime factors you have, find its product. 5 2s are 10 and 10 3s are 30. So this is 30. 3 into what is 60? Hide 3. 2 2s are 4. 4 5s are 20. So that is the next factor. 4. Remember, 4 is double 2. So hide double 2. 3 and 5 are left. What is their product? 3 5s are 15. 5. Hide 5. Next. And product of these 3 factors is 12. Well, are we having more pairs of factors? You can very easily determine that. These both factors, see, factors on the number left hand side, factor on left side and on the right side of the multiplication sign. You observe them. All these factors on the left are smaller than the factors on the right. Once you get a pair of factor where on left and right becomes equal, or right side becomes smaller than, right side factor becomes smaller than the left side factor, then stop there. There are no more further pairs of factors after that. What is the situation here? 12 is larger, so we may be having more factors. Let's check out. After 5 is 6. 6 is composite number. It has 2 factors, 2 and 3. Are 2 and 3 prime numbers available here? Yes. Okay, it is there. So write 6 into, hide 2 and 3, which is 6. What is left? 2 and 5. 5 2s are 10. Still the factor on the right is bigger than that on the left. So we'll have to go further. After 6 is 7. 7 is prime. But 7 prime factor does not exist here. So that means 7 is not a factor of 60. After 7 is 8. 8 is again composite. And in 8 you have 3 2s. Here we have only 2 2s. So 8 is not available here. 9. 9 is composite. Double 3. Double 3 is not available here. And after 9 is 10. 10 you got. 10. Yeah, you said 10. Okay. So 10 into 6. But no need. 6 into 10 and 10 into 6 is one and the same. So no need to write this last pair of factor. So got all pairs of factors. From there you write down the factors. From there you write down the factors of 60. See, in ascending order you get very easily. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 12, 15, 20. 12, 15, 20, 30 and 60. So this is the method of getting the factors of 60. Now 48. Let's see quickly, huh? 48. Divisible by 2. 2 24s are, 2 12s are, 2 6s are, 2 3s are, and 3 1s are. You got number of prime factors. So you will get more pairs of factors as well. First pair of factor, obviously 1 into 48. First pair of factor is 1. 1 is a factor of all number. 1 into 48. Next 2. Yes. 3. Yes. 4 double 2. Yes. 5 prime. No. 6. 2 3s are. Yes. Then you take little breath. Stop here. You write the factors on the other side. 2. So hide 2. 3 2s, which is 8. 8 3s are 24. Hide 3. Next is 3. 4 2s. The product is 16. 2 into 2 into 2 into 2 is 16. 4. Double 2. Hide that. Double 2 into 3 is 12. 6. 2 and 3. Hide that into 8. Well, the right side factor is still bigger than that compared to left side. So we'll have to continue. Look for more pairs of factors if exist. After 6 is 7. 7 is prime. If 7 is a factor of 48, it should be present here. It's not, so it's not a factor. After 7, it's 8. Yeah, 8 you already got. 6 into 8 or 8 into 6. Stop here. So these are 1, 2, 3, 4, 5. 5 pairs of factors of 48. So once you got pairs of factors of a number, you can easily write the factors of that number. Boliye, what are the factors of 48 in ascending order? 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. Correct? In the same way, you can find the factors of 36, 18 and 12, which I am not going to do. You all can do it. In your homework sheet, you will get some more numbers. Okay? Clear? Understood? Now children, we are going to go a little bit out of the way. Means, since we have learned how to obtain the pairs of factors, factors, we are going to see its one application in second chapter where you have to find the factors of quadratic polynomial. Alright, quadratic polynomial, which you have already learnt in standard 10th. Or should I do it in the next session? Yeah, because it is lengthy and it will take time. So I'll continue in the next session. Alright. So I hope you were paying attention. And to those who were inattentively paying attention here please. It's time for me to go. Goodbye. Thank you so much.